operator Marcus Vance positioned a 29,000-pound Caterpillar D4 LGP. The date was February 2024. The machine sat inside SoFi Stadium, facing structural concrete corners that completely obstructed the required expansion. FIFA regulations mandated a 74-yard field width. The existing NFL geometry measured precisely 53.3 yards. Permanent precast seating occupied the 21-yard difference. The facility was an active $5 billion enclosed environment. Extracting structural concrete requires violent hydraulic force. The structural tolerance for uncontrolled vibration harmonics was statistically zero. Standard demolition destroys the underlying subgrade. The stadium floor housed calibrated electrical conduits. Heavy machinery had to operate entirely on engineered protection mats to prevent catastrophic slab failure. The digital timer on the scheduled stadium shutdown initiated. The NFL season dictated a non-negotiable temporal boundary. Vance lowered the breaker attachment to commence the extraction. The mandate originated from the executive level. Rams COO Kevin Demoff defined the structural parameters. The stadium's 70,000-seat capacity could not decrease by a single unit. The solution relied strictly on civil engineering. The static precast concrete required conversion into a retractable mechanical system. The physical footprint remained identical. Manual labor was mathematically insufficient. Caterpillar 308CR excavators, equipped with heavy hydraulic breakers, navigated the narrow concrete stadium tunnels. They systematically dismantled the solid lower bowl sections. The 308CR delivers a specific operating weight of 20,600 pounds. The compact radius allowed 360-degree rotation within the confined seating tiers, without striking the foundational pillars. The breaker bit impacted the precast blocks at 800 blows per minute. Seismic sensors monitored the structural baseline continuously. The vibration remained within strict engineering parameters. As the concrete disintegrated, the material volume expanded exponentially. Compact track loaders shuttled the jagged debris through the narrow stadium exits. The extraction rate was strictly monitored. Airborne silica is a severe hazard indoors. Industrial misting arrays saturated the active work zone. The massive air filtration systems extracted particulates throughout the continuous demolition process. The timeline faced an immovable barrier. Weekends hosted professional football events. Operating heavy machinery in a start-stop sequence fractures standard production curves. The mathematics absorbed the friction. By Monday morning, the equipment returned. The broken precast was entirely extracted. The structural void was completely exposed. The demolition phase concluded efficiently. The mechanical transition dictated the new foundation. A complex matrix of PVC irrigation and aeration piping was installed into the excavated dirt. This system sustains the temporary grass. Before analyzing the subgrade telemetry, if factual equipment metrics matter to you, subscribe. We rely exclusively on verified operational data. What is the tightest grade tolerance you have executed indoors? Thousands of tons of silica sand covered the subfloor. Superintendent Keller deployed the Caterpillar D4 LGP. High-point loads would fracture the intricate PVC systems below. Operating at 29,259 pounds, the D4 distributed its mass across 30-inch track shoes. The ground pressure registered at 4.1 pounds per square inch. This prevented absolute structural failure. The material was specialized silica sand. Vance held a calculated ground speed. The hydrostatic transmission minimized torque spikes during directional shifts. The fragile pipes remained intact. Manual grading was statistically insufficient for the tight tolerances. A Topcon 3D MC2 system integrated directly with the dozer's hydraulics. The GPS coordinates locked into the digital blueprint. Standard GPS relies on satellite triangulation. The solid roof canopy blocked the signal immediately. A local network was synthetically established to maintain the data link. The mechanical evolution of dozers, extreme enclosed projects, and verified technical data live in our membership section. Join for operator-focused deep dives. Now back to the grading operation. A universal total station array was deployed across the field. robotic lasers locked onto the D4's masts. The TopCon system processed spatial coordinates at 100 Hz. The pate blade adjusted its elevation autonomously. The hydraulic response time was instantaneous. The software matched the digital blueprint with absolutely flawless mechanical execution across the grade. The competing force was material compaction density against fragile pipes. Excessive equipment passes would compress the silica, creating a critical threshold that threatened total systemic failure. This is where theoretical engineering confronts operational reality. The spec sheet dictates ground pressure. The operator's physical momentum control guarantees structural survival. Vance floated the machine perfectly. The silica sand behaved differently under the enclosed canopy. Controlled atmospheric humidity altered its swell factor. The dynamic load of the blade required constant tactile readjustment. The D4 transitioned across the critical zone. The subsurface aeration matrix remained entirely intact under the payload. Digital load sensors confirmed absolute zero pipeline deflection. The sand grade was finalized. The 3D topographical map verified the elevation instantly. The entire corner quadrant registered a surface variance of less than 2 millimeters. The mechanical foundation was perfectly set. Heavy structural fabricators initiated the assembly sequence. Massive steel track beds were lowered onto the engineered subgrade by crawler cranes. The heavy steel track guides measured exactly 21 yards. Their installation demanded absolute parallel alignment. A fractional deviation would seize the entire retractable mechanism under load. Laser transit arrays verified the track beds. Anchor bolts penetrated the foundational slab at exact intervals. The stadium's structural geometry was permanently redefined. Heavy motorized bogies were positioned directly onto the tracks. These electric drive units generate massive horizontal torque. They carry the entire dead load of the modular seating tiers. The new seating sections utilize lightweight structural composites. This reduces the operational load on the mechanical drives. The exact visual configuration was mathematically replicated. DMOF's primary capacity parameter was successfully achieved. The active seating remained at 70,000 units. To an observer, the layout matches the original static precast perfectly. Retracting the modular seats physically exposed the deficit. The required 74-yard FIFA dimension was systematically unlocked. The concrete barrier no longer existed. With the seats retracted, temporary turf installation commenced. Rolls of artificial surface were unspooled over the engineered silica sand. The TopCon grading proved functionally flawless. Seam alignment dictated the turf's structural integrity. Specialized tractors pulled the heavy synthetic rolls into position. The ground pressure remained strictly distributed across the sand. The subsurface PVC matrix was pressurized. The irrigation telemetry indicated optimal flow rates. The temporary grass system received precise hydration immediately. Moisture sensors within the silica sand registered peak density. The swell factor remained within the calculated tolerance. The D4 LGP's compaction footprint was fully validated. If this technical breakdown meant something to you, hit the thanks button below. It helps fund the next operational analysis. Let's return to the dynamic retraction test. The mechanical system underwent its initial dynamic cycle. The electric bogies engaged the steel rails synchronously. The massive corner section initiated rearward movement exactly as engineered. The retraction required exactly 45 minutes. Movement speed was intentionally restricted. This minimized dynamic load spikes on the underlying structural foundation completely. The structure locked into its rearward position. Proximity sensors confirmed the mechanical limit instantly. The expanded field boundary was physically established without error. Laser measurement units confirmed the newly created transverse width. The telemetry displayed precisely 74 yards. The FIFA spatial requirement was officially satisfied. The structural transition is entirely bidirectional. The mechanical corner advances forward to re-establish the NFL boundary. The standard geometry is restored seamlessly. The auto deployment eliminates manual heavy lifting entirely. The sequence occurs during standard stadium transition windows. Professional football scheduling remains perfectly unaffected. Seismic baseline data was reviewed. The uncontrolled vibration harmonics during the concrete extraction never exceeded the threshold. The stadium's structural integrity remained fundamentally intact. Traditional demolition would have destroyed the subsurface utilities. The cost of slab replacement would have exceeded $30 million. Targeted hydraulic extraction prevented this financial deficit. The engineering legacy is absolute modularity. A fixed concrete structure was successfully mechanized. The stadium environment adapts mathematically to its shifting parameters. The mechanical contrast is absolute. Heavy industrial machinery engineered the microscopic tolerances required for an organic sports pitch. The sterile environment was successfully manipulated. When the World Cup physically commences, billions of viewers will observe a geometrically perfect green pitch. They will naturally assume the architecture was always there. They will not perceive the heavy hydraulic breakers. They will never understand the ground pressure calculations of an iron bulldozer working aggressively on fragile sand. The engineered subgrade remains permanently buried beneath the turf. The visible evidence of heavy earth moving was systematically erased from the stadium floor. But the operators understand the reality. The stadium architecture functions simply because the heavy iron delivered the necessary grade. The math worked. The extraction machinery was completely demobilized. The excavators and the dozer tracked onto waiting transport units in the Los Angeles staging area. The impossible field geometry was finally resolved. The required dimension was successfully carved straight out of solid foundational concrete using precise mechanical force. Operator Marcus Vance shut the Caterpillar down. The machine executed the most critical phase flawlessly. The structural survival depended entirely on that operational precision. Vance continues operating equipment for complex civil projects today. The D4 LGP remains in active commercial service. Its hours are meticulously logged. Want real equipment content? Subscribe. If you've run iron, comment below. What machine? What job? What is your tightest indoor grade? The SoFi grade stands the D4 pushes on. We read the telemetry.